Hello, practice questions on topic 2, representing motion, lesson 4, how fast, speed, and velocity. Question number 1. Something is the change in position divided by the time during which the change occurred. Of course, it's the average velocity. 2. The figure below shows position time graph for an object in motion. Its velocity at 4 seconds is called its something velocity. It's the instantaneous velocity. You drive a car for 3 hours at 97 km per hour, then for another 3 hours at 72 km per hour. What is your average velocity? Here, if we look at the answers, we'll find that all of them have the same number, so we need to take care of the unit here. So meter per second square is for acceleration, the same here, acceleration, this one as well, acceleration, so the right answer is C. 4. What is the average velocity of an object that moves from 6.5 centimeters to 3.5 centimeters relative to the origin in 3 seconds? Here, to get the average velocity, we need to get the change in position and we divide it over the total time. So 6.5 minus 3.5, which is 3 over 3, so the answer is 1. If it moves in this direction or this direction, we determine which one is positive or negative, because here all the answers have positive signs, so the right answer would be 1, but it's supposed to be negative 1 because it moves in the positive x direction. So the answer is A. 5. When is the average velocity of an object equal to the instantaneous velocity? A, when the velocity is constant. Yes, this answer is right, as in this graph here. 6. The graph below represents the motion of a bicycle. What is the average speed of the bicycle? Okay, here as we said, the instantaneous and the average velocity will be the same in this graph as in the last question. So we take this point, and here is the position, which is 9, and then the time is 15. But we need to take care of the units. Here we have the time in minutes and the position in kilometers, but here we have all the answers meters per second, so we need to convert it. So it's the average velocity is 9 over 15, but we need to convert it to meter per second. So for the kilometer, we will multiply it times 1000, and here for the time we multiply it times 60. So the answer will be D, 10. Question number 7. An object's equation of motion is given by x final equals 12 meters plus 5 meters per second times time, where x final is the final position and t is the time. Which statement is true for the object? Initial velocity could be 12 meters per second, moves with a constant velocity of 5 meters per second. So before reading the answers, we need to know that this formula, which is x final equals x initial plus vt. So the 5 represents the v, and the initial position represents as 12 meters. So here we know that the velocity is constant and it's equal to 5 meters per second. So let's find the right answer. Moved with a constant velocity of 5 meters per second, so the answer is B. 8. Which of the following correctly compares the velocities represented by the graph below? This one is steeper. That means its velocity will be the highest. and then this one, and finally this one. So let's get the right answer. V Ahmed more than Ali more than, so the answer is C. Let's move to the next question. Fill in the blanks. The speed and direction of an object at a particular instant is the instantaneous velocity. B. Ratio of the change in position to the time interval during which the change occurred is the average velocity. C. The absolute value of the slope of a position time graph is the speed, average speed. 2. The graph below describes the motion of a ship drifting slowly through calm waters. The positive x direction along the vertical axis is defined to be south along the vertical axis. So here we have south and here we have north. What is its average velocity? To get the average velocity, first of all, we write the formula. The average velocity equals x final minus x initial over delta t, which is t final minus t initial. So let's get 2 points. We'll take these points here, these 2 points. This is the first one. And let's take for 1. So this will be the final and this will be the initial. So here we have -1 and here approximately we have -0.34, which is 1/3. So it's -1 for the position of the final point minus -0.34 over the change in the time, 3 minus 1, -0.34 meter per second, or we can say 0.34 to the north. Both are right. B. What is the ship's average speed? Average speed, we get the absolute value of the average velocity, so speed or average speed will be equal to 0.34 meter per second. Question number 3. Refer to the diagram below to answer the questions below. A. Find delta t for the change in position from x equals 5 meters to x equals 15 meters. So for the 5 meters, we have the first point here, and for the 15 meters here, so let's draw a vertical line. So here we have 2, and here we have 6. So it's 6 minus 2, delta t equals t final minus t initial. So 6 minus 2 equals 4 seconds. B. Find delta x for the time interval from t equals 2 seconds to t equals 8 seconds. So from 2 we have 5, and for 8 we draw a vertical line and then a horizontal line, so we have 20. So delta x equals x final minus x initial, which is 20 minus 5, 15 meters. C. What is the slope of this line? To take the slope, we need 2 points. Again, the slope is average velocity, so delta V equals x final minus x initial over the change in time, which is equal, let's take these 2 points for the 5 and this one here, so we have 15 minus 5, then 6 minus 2. The answer will be 10 over 4, which is 2.5 meter per second. D. What does the absolute value of the slope of this line represent? It's the speed, and it will be equal to 2.5 meter per second. What is the speed of the object in meter per second? Okay, 2.5. If the object continues at the same speed, how long, so we're asking about the time, would it take this object to reach a position of x equals 150 meters? So now we know that the velocity equals distance over time, or average velocity equals position over time. So now we need to calculate the time, which is x over v. So t equals x over v. The distance or the position is 150 over 2.5, so we'll get 60 seconds. G. If the object continues at the same speed, how far, so we're asking about the position, x, will it have traveled when time or t equals 20 seconds? The same thing, we use the same triangle here. To get x, we multiply v times t. So x, or delta x, x equals v t. Let's substitute 2.5 times 200, which is 500 meters. H. What formula would you use to determine the position of this object if it had an initial position vector and then traveled at a fixed velocity or a constant velocity for a certain amount of time? So the formula will be x final equals x initial plus vt. How far will this object have traveled if it had an initial position of 220 meters and traveled at speed of 2.5 meters per second for 48 seconds? So we just need to substitute the values from this formula. So x final is equal to 220 plus, we open a bracket, 2.5 times 48. Let's calculate this. You will get 340 meters. 4. The equation of motion for a person riding a bicycle is x equals 6 plus 5t. Where is the bike at 2 seconds? At 2 seconds, so we just substitute t with 2 in this formula. So x equals 6 plus 5 times 2, which is 16 meters. At what time is the bike at the location x equals 26? We do the same thing. We substitute 26 for x in the formula. So here we have 26 equals 6 plus 5t t. Now let's move the 6 to the other side. So 26 minus 6 is 20 equals 5t. So t equals 20 over 5, which is 4 seconds. Question 5. The graph below shows how the position of an object is changing with time. From the graph, identify if the object is moving towards or away from the origin in the first 4 seconds. In the first 4 seconds from the graph, it moves towards the origin. So here, towards the origin. B. What is the object's average velocity at 4 seconds? So from this point to this point, let's choose any 2 points. Let's say 3. Here we take 1 point, and then we go the horizontal line is 5, and we can take from 1, we draw a vertical line, then horizontal line. This point is the initial point, and this one is the final. So quickly we write the formula: delta V equals delta X over delta T. Delta X means X final minus X initial. So X final here is 5 minus the initial is 15 over the change in time, 3 minus 1, which is 2. 3 minus 1. Equals, so here we have negative 10 over 2, which is negative 5 meters per second. What is the object's average speed in the last 1 second? The speed here is constant, even here or in this. So it will be the same, but in the opposite direction. So instead of negative 5, it will be 5 meters per second. What is the y-intercept? That one is easy. Y-intercept is 20. E. Use the answers from part B and part D, B and D to find the position of the object after 10 seconds. We'll use the same formula. X final equals X initial plus VT equals X initial is 20 plus V is negative 5 times T is 10. So we'll get 20 minus 50, so it's negative 30 meters. Question 6. The diagram below shows the position time graph for a particle moving in a straight line. In which of the time intervals below is the velocity of the particle negative? Take the appropriate box or boxes. So for negative velocity, so that means this and this. So it's from 2 to 4 and 4 to 5. 2 to 4 and 4 to 5. And this one is wrong. B. Find the instantaneous velocity at 4 seconds as the graph is constant, or the velocity is constant here. So we can take this point. So it's 20 over 2. And it will be negative. So it's negative 20 over 2 because it goes towards the origin or in opposite direction. So it will be negative 10 meters per second. What is the total displacement of the particle? The total displacement is here the final position is -10. Or we can say here from this point to this point it's +20, and then from this point to this point it's -20 here, and then again this position is -10, so we add all together 20 minus 20, 0, and then negative. D. Find the average velocity of the particle for the interval t0 and t5. Average velocity delta v equals x final minus x initial over delta t. So the final position is -10 minus the initial is 0 over delta t, which is 5 minus 0, 5. So it will be -2 meter per second. The graph below shows the motion of an object. A. What is the object's displacement in the first 5 seconds? To get the displacement for the 5 seconds, so it moves from 2 to 3. That means 3 minus 2, so the displacement x will be 1 meter. B. Find the average velocity of the object during t10 and t15. So it's here 10 and 15. The average velocity delta v equals x final minus x initial over delta t, which is equal to, the final point is at the 15, so here we'll get the displacement or the final position, which is 1 minus the initial will be here 3 over delta t, it's 15 minus 10, which is 5, so it will be -2 over 5, which is -0.4 meter per second. C. What is the average speed of the object between t equals 10 and t equals 15? Is it the same question like the previous question? No. The previous question was asking about the velocity, the average velocity. This one is asking about the average speed. So we just take the absolute value of the average velocity. So the answer will be 0.4 meter per second. D. Write the equation of motion for the final position of the object during the first 5 seconds. We know it. X final equals x initial plus vt. Now we put the values, so we'll get x final equals, the initial position here is 2 from the graph, plus during the first 5 seconds we need to get the v. Here we know that v equals final minus initial position, so the initial position is 2 and the final is 3, so 3 minus 1, which is 1 over 5, which is 0.2 meter per second. So we got it here 0.2 and multiply times, or we just put t to use the formula. For each description, complete the table with the correct time interval. The object was at rest at this part because the position doesn't change, so from 5 to 10. The object was moving towards the negative direction at its lowest speed. Lowest speed, it will be this one here, not this one, because this one is steeper, so from 15 to 20. The object was moving at a constant speed towards the positive direction. Obviously, it will be this one from 0 to 5. Thank you.